Consider the non-lifting flow over a circular cylinder. Now, what we want to do is we want to try to find the locations of theta along the surface of the cylinder where the surface pressure is equal to the free stream pressure. Now, in order to solve this problem, all we need is our equation relating Cp and theta. So that'd be Cp is equal to 1 minus 4 times sine squared theta. So now let's write out, so we want to find the thetas where P is equal to P free stream, or our static pressure. So now we can actually make this relation where P is equal to P infinity plus our coefficient of pressure times our dynamic pressure, or Q infinity. So we can say, so if P is equal to P static, then that means Cp has to be equal to 0. So essentially what we're doing is we're trying to find some of these points that I'm highlighting in red here. So that's when our coefficient of pressure will essentially be equal to 0 for a essentially non-lifting flow over a circular cylinder. So what we can do is we can set Cp equal to 0, and we'll have the rest of our equation here. And then we can solve for sine theta is going to be equal to plus or minus 1/2. Now, if we take the inverse of sine for both sides, we then get that theta is going to be equal to 30 degrees, 150 degrees, 210 degrees, and on and on and on, because it's a sinusoid, so it's going to keep going on forever. So essentially, that's pretty much how we solve the problem.